I wanted to share something with you. Let me share my screen about GeoGebra. I have a relation. You see x squared plus y squared equal 10. And this is equation of a circle, as you see in the graph. And this equation, we want to calculate visually what is the slope of the tangent at point A, 3 and 1. So we can discuss about this relation and find dy by dx at x equal 3 and y equal 1. But I think it's better to make it as a function so we can focus our studying about the upper part of the circle, the semicircle, so we can make some change about this relation to make it a function like this. So the same discussion about the relation x squared plus y squared equal 10 is the same as, because our point is the upper part of the relation, so we can discuss about the semicircle y equals square root 10 minus x squared, because we have already this point in this part of the relation. So we will discuss 4 methods about getting the slope of tangent about this at this point by using 4 visual methods. We will first make a method explained by zooming in of the curve at point A. So if we zooming in at A and make it several times, we can deduce that the curve approach to be a straight line. You see, before it was a curve, but after zooming in, its approach to be a straight line. So our method depends on zooming in several times, like this. And after zooming in several times, the curve approach to be a straight line. So we can choose a point close to A, like point C. This point so close to A. So if we get a straight line passing through A and C, its approach to be a straight line because our zooming in makes the curve approach to a straight line. So if we connect A and C to make a straight line AC, and we ask it GeoGebra about what is the slope of the straight line AC, which is called H, our answer is -3. If we return to zooming out to see what this straight line and what is the slope of this straight line, you can see this straight line is a tangent to the circle, to our relation at point A. You see? Now we can see that this straight line is a tangent to the relation at A, and its slope, by drawing right angle triangle, it's -3 over 1 equals -3. Okay. Now we can move to another method to see how the tangent at x equal 3 is -3. We have another method, and this method depends on to draw a secant. If we choose another point on the curve like B on the curve, and we can make this point moving on the curve like this, and if we draw the line AB like this, and if A equal x1, y1, B x2, y2, if we calculate y2 minus y1 over x2 minus x1, that means we will get the average rate of a change from A to B. And this means the slope of the secant AB. And we can ask GeoGebra also to calculate what is the slope of the straight line AB, which is called G. And our slope, the slope of this secant, it will be -0.43. But if we make B closer and closer to A to make the secant approach to tangent to the circle when B is so close to A, we can find also visually the slope of tangent at A. So we have in GeoGebra the slope of the secant, and we will try to make B closer and closer to A. B is moving in our circle, and now B is approach to A, and that means the secant approach to B a tangent to the circle. Now we can zoom in to see how is B approach to A and what is the slope of the straight line of the secant in this case. When B approach to A, you will let B moving like this. Still AB is a secant, and B approach to A. That means the average rate of a change approach to B instantaneously rate of a change. And when we let B closer and closer to A like this, at this moment, we can ask what is the slope of AB, and GeoGebra calculate the slope. It's -3.462. And we can make B closer and closer like this, so close to A. So we see that the slope of this straight line so close to -3. Okay. Okay. Now, thank you, B. Thank you, line AB. Thank you, slope of the secant. Now, we can check our solution. The slope in the first case was -3, and the second case also approaching to -3. What about if we have a tangent line? We ask GeoGebra to draw a tangent at A for our circle. And our tangent is 3x plus y equals 10. And if we ask GeoGebra to getting what is the slope of this tangent, the slope of f, because this tangent here is called f, and our slope is -3. You will see that if we have a right angle triangle like this, the slope will be -3. So by the first method, we have the slope of tangent at A equal -3. By the second method, by using the secant, the slope also is -3. By asking the GeoGebra about to calculate the slope of the tangent at A, the answer also -3. The last method, we can find by using GeoGebra the first derivative of this function. Of course, I mean about, if I called it this function, I mean about p of x equal square root of 10 minus x square. So if I asked GeoGebra about, can you draw to us the slope of the tangent, I mean the first derivative of this function. So the first derivative of p, because our function p in the case of square root, positive square root of 10 minus x square, because a equal 3 in this part of the relation. So if we ask it about what is the first derivative of p of x, we have here p prime of x, the derivative of p equals -x over a square root of -x squared plus 10. So if we asked GeoGebra to find this slope of tangent at x equal 3, we can substitute by -3 here. It will be -3 in the denominator, and -9 plus 10 equals 1. It will be -3 over 1 equals -3. We can also ask GeoGebra to calculate it. In this case also, c equal p prime of 3, he can substitute and calculate it for us. It's -3. So by using the first derivative and substitute by 3, we will get the same answer. If we look at the graph of p prime, it will be amazing to get the same answer also. P prime is the green curve, which is the first derivative of the red curve. So if we ask it, what about the value of p prime at x equal 3? At x equal 3, our answer here, at x equal 3, p prime, it's -3 also. So by zooming in to get the slope of tangent, the answer will be -3. If we make the secant and make the other point approach to 8, the slope will be -3. If we ask it GeoGebra to calculate the first derivative at x equal 3, the answer will be -3. If we looking at the curve of the first derivative of this function and ask it about when x equal 3, what about p prime? What about the first derivative? The value will be -3, as you see. Okay. I hope you enjoy this explanation. Thank you.